So we've got salt and pepper.
That's a good pair.
Yeah.
Husband and wife, they're kind of a
That's
pair.
good. We have the night sky and morning.
Yeah.
Day night. They are.
Jesus and the Big Bang Theory.
Oh, that's a really clever pair, aren't that? Pairs.
They're a good pair.
They're a good pair.
Conjugate pairs.
That's a good one. And pairs of socks, of course.
Yes, but we should probably focus more on the conjugate pairs at the minute.
Yeah, and conjugate pairs of acid and bases.
In particular, yeah. Okay, so
Right, let's do that. So, you know that when an acid is put into a solution, it splits into H plus ions and Cl minus ions.
Yeah, but it's not quite as simple as it sounds.
No.
So
So
we've got
you have HCl, for example.
This is the easiest acid. Well, the same application for the other acids.
Yeah, but it's a nice one to write down, only two things. And then we have water. That's what happens when it gets into aqueous.
Yeah.
There is water involved. So you end up with H plus ions and Cl minus ions, but
What I'm going to do is first I'm going to write this underneath HCl aqueous, which means it is with water.
yeah,
So this is just an overall goes into H plus and Cl minus, as we know, just like
yeah.
that.
We know that happens, but does it?
Well, not quite. The H plus is actually a bit more jazzy. When we find out what the H plus is truly equal to, we'll come back to this top equation.
Okay. So what the H plus does is it basically bonds to our water.
Yeah. Water is amphoteric. It can have both acid and basic properties.
Yeah. So here it's acting a bit as a base because acids don't actually donate their protons unless there's anything to give them to.
Yes. So it's going to give this H plus to the water. It's going to make a positive ion overall.
Should be hydrogenium or oxonium or something.
Yep. So you had the water as it was before, and this
Yeah.
is just simple covalent bonding.
Yeah. Should be
So you've got
very familiar with from
Hydrogen
before.
there. Then your hydrogen donating there. There's an electron from the oxygen in each of those.
And it's got two lone pairs. Now this hydrogen bonds to one of these two lone pairs.
Forming a dative coordinate bond there.
Yeah.
And then you put it in your big square brackets because overall it's positively charged.
And then remaining you have your Cl minus.
So what we can do is we can put this, after Triv's drawn that, we can put OH3 up here. So if it's just in water and there's nothing else in there, there's nothing else the ions go to. So overall, we've got, I'm going to draw in red, H3O plus, and then in blue we've got Cl minus. And that's what's really going on, and the plus in between, I'm doing black.
Oh, sorry.
And that's what's really going on if it is just in water. That's what's really happening as opposed to this one here. Because acids don't donate their protons unless there's nothing to go to, as we've said.
So if they did, they just all remove their protons. As soon as they hit water, there'd be millions of hydrogen positive ions floating out of water. But actually, there isn't.
And a rough number in the book, just to give you a rough inclination of how little protons there are free moving in water, is 10 to the power of minus 130. That's a concentration, so mole per decimeter cubed.
Yeah. I'll write that down as well.
So 10 to the 130 is a massive, massive, massive number. And if you do maths, you'll know that minus means 1 over this massive, massive, massive number.
So it's a very small amount of them actually available at the time. So they only actually appear when there's stuff for them to arrive to. That's when the pull arrives, and that's why they separate.
And that's what this chapter's about. And the conjugate pair is because if it's water, it's got that nice little conjugate pair there.
Yeah, but another word for a lone pair, it makes a covalent bond. Or a coordinate bond, as you're often calling it, A2.
Yeah. And that's that. That's
Yeah.
this chapter done. Let's move on to pH, because there's also some hidden truths in there.
Oh wow. I was thinking we should get a pair of cups of teas now.
Oh, that's good. And a pair of chips.